Okay, today, lesson 31, we're going to do a couple things. We're going to add integers, and then we're going to use that skill to collect like terms. We'll talk about like terms here in a second, but let's start off by giving you a couple rules of addition here. Let's get these written down. Start off with a rule for adding numbers with the same sign. So they're both positive or they're both negative. What we do when we have numbers with the same sign is we add their absolute values together and we keep the sign that they have in common. So if you're adding two positives, your answer is going to be positive. If you're adding two negatives, your answer is going to be negative. Just add their absolute values. Now when we're adding numbers with different signs, the task is a little bit more complicated, I guess. What we do is we subtract their absolute values. So the bigger absolute value minus the smaller absolute value, and then we keep the sign of the number with the bigger absolute value. And I'm going to give you a quick definition here of like terms, and we'll talk about this more in a second, but they're terms with the same variables. Could be just one variable, could be more than one variable, and the same exponents. So we'll see those here coming up. All right, so let's start off. We're going to simplify these four expressions. We're going to add them. We've got different combinations of positive and negative numbers here. Let's first look at whether each one is going to become positive or negative. In A, both these numbers have the same sign. They're both negative, so our answer is going to be negative. In B, we have different signs, so what we need to determine is which one has the greater absolute value. Negative 12 is further away from 0 on the number line than 3 is, so it's got a bigger absolute value, so our answer is going to be negative. On C, 12 and 3, again, well, this time positive 12 has a greater absolute value than negative 3. It's further away from 0 on the number line, so our answer is going to be positive. And then on D, we got a negative 3 and a positive 12. Really, this is the same problem as C because addition is commutative. So this is going to be positive as well because positive 12 is bigger than negative 3. Okay, back up here to A. Numbers with the same sign, add their absolute values. 12 plus 3 is 15. So our answer is negative 15. Numbers with different signs, subtract their absolute values. So we'll do 12 minus 3 is 9. C, numbers with different signs, subtract their absolute value. 12 minus 3 is 9. And same thing on D, numbers with different signs, so subtract their absolute value. 12 minus 3 is 9. And there's our four answers. I guess another combination that we could have on there is positive 12 plus positive 3, but that's pretty obvious that that would be 15. All right, so let's show how this works on a number line. We'll do positive 3 plus negative 4 on a number line. Let's make our number line here. I'm going to run mine from negative 4 up to 4. I'm going to start at positive 3, and then I'm going to go backwards 4 places. because it's a -4 that I'm adding. So if I start at +3, that's my starting point. I'm going to add a -4, so I'm going to go backwards 4 spaces, and the number that I end up with, or end up at, is my answer, -1. +3 plus -4 is -1. Let's do some real-world usage of adding and subtracting integers, or adding integers. At 6 a.m. the temperature was -12 degrees Celsius. By noon the temperature increased 8 degrees. Write an equation for this situation and find the temperature at noon. Okay, let's go with T for temperature equals -12 plus 8. Now I know I'm adding 8 because it says the temperature increased 8 degrees. So -12, you know, there's a negative integer used in the real world, and it rose 8 degrees. These numbers have different signs. The number with the bigger absolute value is negative, so our answer is going to be negative. And then we'll do 12 minus 8. Subtract their absolute values, and we'll get 4. So -4. In other words, the temperature ends up being -4 degrees Celsius. Another one. The hikers started on the desert floor, 182 feet below sea level. After an hour of hiking, they had climbed 1,018 feet. Write an equation for the situation and find the hiker's elevation after an hour of hiking. Okay, so we'll go with E for elevation equals -182 plus 1,018. So -182 because they're 182 feet below sea level. Okay, after an hour of hiking, they climbed 1,018 feet. So that means they added 1,018 feet to their elevation. All right. So these numbers have different signs. So, but obviously 1,018's got a greater absolute value than -182. So I know my answer is going to be positive. We're going to be above sea level. And then I'm supposed to subtract their absolute values. So instead of using a calculator, I'm going to come over here, subtract their absolute values. Do some borrowing here. So it's 836 is my answer, positive 836, which means they are 836 feet above sea level. Okay, collecting like terms. Now I give you a definition of like terms as terms with the same exponents raised to the same, terms with the same variables raised to the same exponents. So on the first one, starting with that 3x, -x and 3x are like terms. They both have an x. Now 2xy and xy, they both have an x too, but the fact that they have that y there makes them unlike terms with 3x and x. 3x and -x. So what we do is we add their coefficients. The coefficients are the numbers in front of the variable. This one is 3. This one it's -1. 3 plus -1 is 2. So 3x plus -x is 2x. And then these two are like terms because they both have an x raised to the first power and a y raised to the first power. 2xy plus 1xy is 3xy. And that's our answer. Okay, moving over to I, 6x squared. Does that have any like terms in the rest of this expression? No. I see some x's, but no x squareds. So 6x squared is the only x squared term. Then I'll look at this -x. 2x is a like term. They both have x raised to the first power. So we do -1 plus 2. -1x plus 2x is positive 1x. You don't write the 1. You don't need it. Just like right here, we didn't write a -1. We don't need that 1. -1 plus 2 is 1, so it's 1x. And then lastly, we got this -1 here. We're going to bring that down and include that too. Last one, 2a cubed and -a cubed, those are like terms. They add up to 1a cubed. You don't need the 1. And 3b plus -4b is -1b. Again, you don't need the 1 there. So, can't make this more clear. Don't write 1s that you don't need. We're not going to write a 1 in front of this. We're not going to write a 1 in front of this. We're not going to write b to the first power. We don't need those 1s. Some more combining like terms here. X and -x adds up to 0x. X minus x is 0x, or 0. So we're not going to write anything there. As opposed to y plus y, that's 2y. And then lastly, negative 1 plus 1 is 0, so we're not going to write anything there. Our final answer is 2y. Next one. Simplify this equation here. We got L plus L, that's 2L. And we got W plus W, that's 2W. We're going to use that on the next example. Perimeter of a rectangle, 2 times length plus 2 times W. And then lastly, S plus S plus S plus S is 4S, so perimeter equals 4S. That would work for a square where all the side lengths are the same. So we could just go 4 times the side length instead of going side length plus side length plus side length plus side length. Last example for today, let's do this. Let's find the perimeter of this rectangle where we don't know what the length is and we don't know what the width is, but we do have expressions that represent the length and the width. So we'll go all 4 sides added together. We got an x, we got an x, we got a 3y, we got a 3y. And we can simplify this and combine like terms. X plus x is 2x, and 3y plus 3y is 6y. So the perimeter of this rectangle is 2x plus 6y. That's all I've got for you today, and we'll see you in here tomorrow to work on problem set 31. See you then.